In this video, we're going to look at integrating products and quotients. So in other words, when our integrands are multiplied or divided by each other. And we must remember that before integrating, we have to express the function as a sum or difference of its individual terms. So in the first example, we want to find the indefinite integral of the integrand 3x minus 4 upon 2x plus 2 with respect to x. So the first step is to expand our brackets in order to express our integrand as a sum of individual terms. So we get 6x squared plus 6x minus 8x and minus 8. And that's with respect to x. So the next step is to rewrite our integrands with the coefficient in front of our integration symbol. And we're also going to collect our like terms. So 6x take away 8x will give us minus 2x. And remember that a constant term has an x to the power of 0 as its power of x. And then we need to apply our rules of integration, which are raise the power, divide by the power. So we've got 6 multiplied by x cubed over 3, minus 2 multiplied by x squared over 2, take away 8 multiplied by x to the power of 1 over 1. And then remembering our plus c for our constant of integration because this is an indefinite integral. Now we need to simplify our fractions so that we have our final answer in its simplest form. And then we can rewrite the integral of this function as 2x cubed minus x squared minus 8x plus c. So the next example, we want to find the integral of r squared plus 1 over the square root of r with respect to r. So firstly, we need to resolve the fractional indices. We know that the square root of r is r to the power of a half, so we can rewrite that numerator as r to the power of 4 over 2 plus r to the power of 0 over 2, all over r to the power of a half, and that's our integrand with respect to r. We're then going to split it into separate terms. So we've got r to the power of 4 over 2 over r to the power of a half with respect to r plus r to the power of 0 over 2 over r to the power of a half with respect to r. And then we need it in an integrable format. So that gives us an integrand of r to the power of 3 over 2 with respect to r plus r to the power of negative a half with respect to r. Then we're going to apply our rules of integration. We're going to raise the power. So r to the power of 3 over 2 plus 1 is r to the power of 5 over 2 divided by 5 over 2 plus r to the power of a half over a half plus c. And that is simplified to 2/5 of r to the power of 5 over 2 plus 2 times r to the power of a half plus c. And then we can write this in root form as 2/5 of the square root of r to the power of 5 plus 2 times the square root of r plus c.